So today we are going to understand the fundamentals of agentic AI systems. And the term which you have to remember is autonomous, which means we want machines to think, to act, to plan, and to become the task oriented, goal oriented. So we want them to achieve goals. But before we deep dive into what agentic AI systems are, what are their frameworks, what are agents, how they connect to external system, it's better to understand how this journey has been started. So everything is in the slides, but what I'm going to do is I'm not going to go through slides. I am just going to draw everything here live so that we can understand how different things are connected together. So my name is Yogesh. I am having almost 20 years of experience in IT industry, and I will be your instructor for today. So let's get started. Now I am going to have this blackboard. Now, when we talk about this AI, so this is a broader term, artificial intelligence. And as I always say that we divide this in two different alphabets. One is artificial, one is intelligence. Now, what we want intelligence to be incorporated into machines so that machines can do human-like work. Obviously, they cannot replace humans, but we want them to think like us, to act like us, to plan like us, and achieve the goals. And that is where this entire AI started. So AI is nothing, it is mimicking the human intelligence into machines. And when we talk about use cases, there are multiple use cases. So we have driverless cars, we have facial recognition, we have recommendation system, personalization, label detection, NLPs, and much more. They all come under AI. So whatever innovation you see, that innovation is actually belongs to AI. But for AI, there is one thing which is very important, and that thing is called data. How machines will going to get trained? They are going to get trained on data. But the problem with data is it is highly unstructured. So we have different type of data. So we have largely we have unstructured data. So when we have unstructured data, we cannot use that unstructured data, feed them into machines and ask machines to do, the magical things using unstructured data. Impossible. Although we have some semi-structured data and structured data also. But what we want to transform this data so that machines can understand that. And that is where machine learning steps in. Machine learning means we want to have a clean data. So there is a process of cleaning the data, right? That is where machine learning comes in. And there are different types of learning there. So you have supervised learning, you have unsupervised learning, you have reinforcement learning. So those type of learnings you can incorporate with your data because data will be of different types. So we need to see which data fits which type of learning. And basis on that, what we do is we clean our data. And once our data is clean, now we can use that data to feed into machines and do magical stuff automatically. Now, this is what is machine learning. But since last 5 to 10 years, this data is growing exponentially. Exponentially, it is growing. And what is happening? The type of data is also getting increased. So there are different type of data now, and it is exponentially growing. So machine learning is unable to handle that because data is becoming complex. So we need more robust models there. And that is where deep learning comes in. So for deep learning, we have some robust algorithms which are based on artificial neural networks. They are same like human brains. So their design pattern is like human brains. So what we want are complex data, super complex data, tons of data, large data, different type of data to be handled and to be cleaned. This is where deep learning comes in. So till 2017, 2018, we were having only these three terms: machine learning, artificial intelligence, deep learning. And we were completely focusing on cleaning the data so that that data can be fed into this system for machine learning or for artificial intelligence. So we were just solely focusing on this area. Data, take data, put data into machines, and then machines can do some magical work. So it was all revolving around data. Data which is available, the clean data. I'll just write in a simple layman language, clean data. Now we have data. So the community, the techie community, they started thinking we have data. Can't we generate a new data out of it? Now we already have a data. This is clean. And this is single type of data. Now can't we use this data and generate a fresh data out of it? So everyone started thinking into it. And that is where a term called Gen AI came in. Gen AI, generative artificial intelligence. What we want, we already have a clean data. Now we want to interact with this clean data and we want to produce new data. We want to generate data out of clean data. Simple. It was not available till deep learning. It was all about having the data, not generating the data. But when Gen AI came, it changed everything. Now you can write codes, you can write music, you can write poems, you can generate images, you can generate videos, and so on and so forth. What we are doing, we are generating data here. We are generating data. And how this data is getting generated? This data is getting generated from the data which is already clean. And that data is actually cleaned using machine learning or deep learning. So we are using the data sets and we are generating new data. So you have multiple sources. Let's say database 1, you have database 2, you have database 3, you have database 4. And there is a different type of data here, different type of data here, different type of data here and here. Using generative AI, we are leveraging this data and we are creating new data out of database 1, database 2, database 3, and database 4. This is what generative AI is. And at the backbone, when we talk about generative AI, there is something called transformer architecture. Word by word, step by step, the new data is getting generated. Many permutations and combinations are acting under the hood. Right? So when we talk about machine learning, there are certain use cases like customer feedback analysis, demand forecast, weather forecast. When we talk about deep learning, complex systems will come like sentiment analysis, medical image analysis, recommendation systems, NLPs. They all are the example of deep learning. And when we talk about generative AI, now whatever you use to create fresh content, that is actually generative AI. Art, creativity, music, summarization, email compositions, right? Everything is generative AI. Now, when we talk about generative AI, now what I'll do is let me create it in an umbrella so that you can understand it clearly. So what do we have is we have this larger ecosystem. This larger ecosystem is called AI. This entire larger ecosystem is AI. Under this AI here, we have machine learning. Under this machine learning or under the subset of AI and ML is DL. And now you need data. Under here, you are having something called Gen AI. Gen AI. Now, when we talk about Gen AI, generative AI is a common term, but there is a brain to generative AI. And that brain sits right here. And that brain is called LLM. LLM, large language models. Right? These are called large language models. These are the models which are trained models. These are trained on tons of trillions of data. Trillions of data. You ask anything, they will give you the answer. You talk about 1990s, you talk about 1980s, you talk about 2010, you talk about 2020, 2025. They will going to give you the data because they are trained on massive amount of data. It means when you talk about generative AI, we talk about ChatGPT. ChatGPT is just an interface. The brain of that interface is LLM. And when we talk about these LLMs, there are multiple LLMs available. You have GPT-4, GPT-5, Google Gemini, you have Llama, you have DeepSeek, you have Claude 4, you have Sonnet. There are many LLMs. But majority of the time, we always come across GPT. GPT-5 is the latest one. We have Gemini from Google. We have Copilot from Microsoft. We have Llama from Meta. We have DeepSeek. Many. Now, when we talk about generative AI, what we are actually talking? We are actually talking about generating data. So what happens till here? There is one database. Think about it. There is some database, right? There is some database, a large database, which is nothing, which is LLM. And then there is one interface, which is connected to it. This is GUI. This is just UI. And we are users. We interact with it. What is artificial intelligence? Can you tell me about containerization? Can you tell me how recommendation system works? Can you give me the fresh news for today? Or so on and so forth. So whatever you write, it go here, create a new content for you and display it. You do cross questioning. So what you can do is you can put questions and you can get answers. Now, when you talk about questions and answers, this is where generative AI is the best, which means the purpose is just reasoning, questioning and answering, and the work is done. It cannot go beyond that. And that is what have governed the entire industry since 2021, 2022. So in last 3 years, every organization is trying to build and is trying to use something like this. Example, a simple chatbot. Now, if I have to give you a very simple example, which many organizations have implemented, it's like this. Now there are multiple employees in every organization, right? Let's say multiple employees. And every organization is having their own policies. Let's say we are talking about HR policies, right? HR policies, leave policies, maternity policies, paternity policies, and so on and so forth, holiday calendar, and so on and so forth. Now, what they do is they either create their own LLM or they take the LLM from outside, like GPT or Gemini or Llama, and then they fine tune that. They make that to just give the answers related to their policy. So they fine tune that. What happens is your LLM is trained on your policy. So it will just going to give the answers which are related to your organization. And then you need not to go to HR. You need not to email anyone and wait for 2 hours, 3 hours, 5 hours, one day to get the answer. No. What you do is you just going to log into your or log into that GUI or just go to that GUI which is internally available for your organization, and as an employee you can interact. Can you tell me the leave policies? It will go to LLM. LLM will actually going to refer whatever data we have provided and it will going to give the details to us. All details. Now let's say again one very important thing. Let's say after 1 year many new data came and you have external database. Let's say this is external database where you store your fresh data, new policies, updated policies, you put a fresh data. Many a times practically it is not possible to keep your LLM up to date because it's trained on tons of data. So you cannot change it every time. Then a new term came in the industry which is called RAG. I'm just writing it like this in a box. RAG. Retrieval Augmented Generation. You have fresh data, you can actually integrate this fresh data with your LLM. Example, you asked, can you tell me which new policy in my organization has been added in last 1 month? 1 month. Now that query will go to LLM. LLM is not having that data because it's not trained on that data. Here the data is 1 year old. Then what it will do is it will actually going to leverage RAG. It will go here, query thing, extract things, bring here, change it into the human readable format, and it will going to give the answer here. This is called RAG. Now, why I am explaining it? Because there are many organizations which are using this ecosystem till date. They are having LLM, which is on which their massive data is trained, and then to feed new and fresh data, what they do is they use something called RAG. RAG means you are feeding real-time data. That was one of the limitations of LLMs earlier, which are overcome by using RAG. Right? Now, this is what is all about, interacting with data and getting the answers. So questions and answers. Then again, the next wave of AI came. We don't want to restrict ourselves with questions and answers. We want to go one step ahead. We want to define goals, and we want machines automatically achieve those goals. And that is where the next evolution of AI started. And that is where AI agents and agentic AI came into existence. Now, let us understand it in a very simple way. So first of all, what I'll do is I'll try to explain you what are AI agents, because these terms majority of the time create a lot of confusion. What is AI? What is agentic AI? What is AI agents? And so on and so forth. So what we will do is we will try to understand how they all work, right? So what I'll do is I'll come back here, right? Same system. Let's say we have our employees and we have our LLM, which is for questions and answers, right? And this is where majority of the questions and answers will be answered. Now, let's say you have your HRMS tool here. HRMS tool. This is tool. This is a tool where you can apply your leaves. You can check your leaves, right? You can do rest of the things where human intervention is required. So I'm just taking two examples, checking leaves and applying leaves. So you can check your leaves, you can apply your leaves. Now, if you ask your LLM a simple question, can you please tell me how many leaves do I have in the current year pending? How many leaves are pending for me? This LLM will not going to give you the answer of that question, because it is just data. Whatever is available here, it can just give you the answer of that particular data. Now, what we are asking is, we are asking something which is available in this particular tool. Now, what we want in between, we want one layer. One layer. That layer is capable enough of understanding and interacting with LLMs, and it is capable enough of interacting and integrating with your HRMS tool as well. So you need some kind of a logic here. So you need some logic here. Something as a prompt is coming. That prompt is going to this logic. This logic should go back here, extract the information of this employee like name and IDs, right? This is first step. Then create a plan, something, and then go back to this HRMS tool and connect with that. Once connected, it should extract the information from here, right? And then it should give that raw data to your LLM. And then LLM with the prompt and the raw data generate a new content which is user friendly and provide the information to this employee. Hey, your employee ID is this, your name is this, and you have, let's say, 4 annual leaves pending. Another use case. Now what happens is, let's say this employee want to apply for a leave. Now, when you want to apply for a leave, you need to go through this entire process. This logic is nothing. This is called AI agents. AI agents. Now, these are the agents which are actually performing all these tasks. And this additional layer is actually providing us something which is called autonomy to do the work automatically. But again, a question came. What if more complex tasks comes and I have agent 1, agent 2, agent 3, agent 4, and multiple other agents? What will happen in that case? The complexity will increase. Now, what do you want? You want a boss. Here, I want a boss. When I say boss, I'm talking about an orchestrator, the one who can manage this entire workflow. So I want someone with controlling ability to control these all things from where the prompts are coming till here, where the tools integration are there, and then the response back. So I want one controlling authority to be here. And this controlling authority is actually called agentic AI. Agentic AI. When we talk about agentic AI, we are talking about goal in mind. The goal is to create agentic AI systems for my HRMS, leave application, application checking, or whatever else this HRMS tool is capable of. So I want to achieve this goal. So you have a goal in mind. To achieve this goal, you are going to use agentic AI, which is nothing, which is an orchestrator. And to achieve those tasks, actually, we have the crew. That crew is called agents. So we have agent 1, agent 2, agent 3, agent 4. These agents are the one who are actually understanding and doing, all logic oriented tasks. The entire logic is actually being executed by these agents. But the important part is communication with LLM, integration with multiple tools, right? Communication within agents, right? The flow of the tasks, the flow, how to connect to a tool, when to connect to a tool, those all things are actually taken care by your agentic AI. So when we talk about agentic AI is nothing. Agentic AI is a system wherein we are having goals set. And we want machines to have maximum autonomy to do work automatically. Obviously, humans will not go away. Humans will always be in the loop. You cannot rely upon agentic AI or AI agents to do complex, highly critical tasks. So we have to have humans always in loop. And we will understand it why, because there are many places where you need humans, right? So this is what is all about agentic AI, right? And we are going to explore it and understand all these terms like tools, frameworks, agents. We are going to do such kind of demos live, and then this picture will going to be absolutely clear to you. Now, next, when agentic AI systems or agentic AI term comes, there is always going to be a comparison between how agentic AI is different than Gen AI. Gen AI and agentic AI. As we have already understood, when you talk about Gen AI, the purpose is questions and answers. That's it. This is the final use case. There is nothing else. You have data, trained data, you are interacting with that data in super simple way. Example, ChatGPT. Example, Copilot. And there are many other examples available, right? All chatbots, they are actually like this. You give this, I will do this. You give this, I will do this. So this is how generative AI works. It's just questions and answers. But when you talk about goals, achieving something without humans, that is where agentic will come into a picture. Many things, many examples. Just think about, you want to check a weather for, um, let's say you want to check a weather for next 10 days. And basis on that, you want to book your tickets. And you want this to happen automatically. Basis on the temperature, you want to book the tickets. Example, you have given a prompt to check European cities or European countries and let's say Middle East. And you want automatically this system to provide you the best location, plan your entire journey, book the tickets, and finally provide you the entire details. So you have goal to check and select a country, And then basis on that, prepare an itinerary, and then finally you want to book the tickets. You don't want any human intervention to be there. That is what is called goal. So you have two goals here, and the final goal is the ticket. So you are going to achieve that using agentic AI. Do we think the generative AI can book the tickets for us? No. Do you think the generative AI will go and check what is the current temperature in London, in Paris, in some other countries, and then come back and give you the recommendation? Take this. This is the itinerary. These are the details, and so on and so forth. No, they cannot. They are not meant for such kind of use cases. For such kind of use cases, you need to move towards AI agents and agentic AI. Right? This is what is the major difference between Gen AI and agentic AI. This is question and answers. This is goal oriented. You always have a goal in mind. And basis on this goal, you create your agentic AI systems, which is nothing, which is actually developing the agents to perform the tasks and managing those agents. Right? Now, in this entire ecosystem, there is one thing which always comes into play. And that one thing is how industry is getting impacted. Now, when you talk about agentic AI, in last 1 year, there is a big movement in organizations for building agentic AI autonomous systems. Now, few real-time implementations which we have seen and which are there in the demand in the industry are: number one, the HR and payroll automation. I'm just writing HR automation. HR automation. Now, this is where majority of the companies have started work, and many companies have already implemented it. So agents are autonomously managing the leave requests, payroll calculations, employee onboarding using your HRMS integrations. This and second use case, which I came across recently with one of the companies, the onboarding of the employees. So employee onboarding. This is wonderful use case. Why? Because in every organization, let's say 5 times in a month, you have this repetitive process, right? So there will be onboarding, there will be deboarding. So in fact, one of the use case should be deboarding also. When we used to go to multiple departments, take the, checklist to them, and then, do all those things, come back and blah, 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 all those stuff. This all can be automated using agentic AI systems. One of the best use case. The other use case, everyone have fed up from something called static chatbots. Now, when you talk about any product company, they have products, so they provide services. Example, Make My Trip. So when you talk about Make My Trip, let's say you have booked your tickets and you want to do some change. If you want to do some change, you again going to call them or chat with them. So when you do a chat with them, that is actually a static chat, which is slow because it just trained on this set of questions which they have. Now, this is something which is getting transformed drastically. We don't want static answers. We want data sources to be there, and we want it to go to a next level with speed, with velocity. That is where customer services will come into picture. It is very important use case. So customer support and services. Yes. I can tell you one use case here will be very useful for you. Now, let's say there is an organization. Let's say a traveling company. Now they have different type of products. So product one is general query. Product two is sales. Product three is after booking support. right? After booking support. So you have booked your tour and you want to change something, such kind of support. Now, what companies are doing now is the data for this is different. So they have different, let's say LLM for this. Considering a case, different LLM. Generally, we have a same LLM. And let's say for sales also, they have different LLM. And for support also, they have different LLM, different sources. Or let me make it simple so that you should not get confused. Let's say they have a generic LLM, which is connected here, which is connected here, which is connected here. And then they have specific data, fresh data. Let's say this is DB for generic queries. And then they have another DB, which is for sales details. And then they have another DB where the booked details of the travelers are available. Now, when anyone is prompting anything and asking anything, we make this entirely agentic. How? These all are going to be agents. Agent 1, Agent 2, Agent 3. No human. These all are machines. As soon as you put a query here, what will happen is with the help of LLM, the context will be extracted. Example, I want to change my flight for my travel, which I have booked on date so and so. So what it will do is it will extract the keywords, context out of it. And then basis of it, what will happen is the agentic framework which is being used, it will going to reason it and then plan. In planning, it will identify, okay, this question is for this agent. It will automatically going to get routed here. So it will not going to be time wastage here, time wastage here. No, it will directly going to be routed here. Then the logic will automatically going to be implemented here. Extracting the details, it will automatically going to connect to the tools, extract the details, extract the hotel and the airline which has been used during the booking time. Then automatically it will check either there is an option to change the flight date and either there is an option to change the date of the hotel. If yes, all those logics will be calculated, bring all that data here. LLM will going to write it in a very simple, polite language and it will going to be displayed here. All done. Just within a matter of 30 to 60 seconds, this entire information will be extracted and provided to user. All done. No humans. And then if they want to do it, it will be like this. Yes, this is possible, but it will be for, let's say, additional 5K INR. And your dates will be booked from this to this. Your hotel will be changed from this to this. Do you want to proceed with it? Yes. Again, same thing will happen. Everything will happen automatically. And the final details will be sent here as well as on email. All done. This is very demanding use case in the industry, especially in traveling companies. Make My Trip, Yatra, Expedia, all are running behind it. All. This is what is customer support and service. And this is equally applicable to any product company. If you have a product, you have services and support. You don't want humans every time. What do? Is you create agents, right? This is very good impacting use case. Let me remove this and come to few more which are important. One of the use case which we came across during the discussion with one of the customers was the finance. Now, finance and accounting is one of the most difficult streams to handle, right? And accounting. This is one of the most difficult, and you have multiple members in a team who are doing specific tasks over and again. Example, um, you are reconciliation of your transactions, detecting anomalies, generating financial reports, um, full and final of an employee, and so on and so forth. You can actually create agents for performing all such tasks. Now, the last one where you will see a great interest by technical people. It's IT operations automation. IT operations. I have been a part of IT operations for more than 10 years. So I know the painful areas here. We get repetitive tickets. We get the tickets which can be handled very easily by automation. And there are many other, tickets where minimum or minimal human intervention is required. Now, what companies are doing is they are trying to create agents for that. They are not humans, they are actually machines. They are AI enabled agents or agnostic agents. They will monitor your infrastructure, they will resolve your alerts, they can deploy the application or upgrade the application, and even there might be multiple agents with which they can connect and do the things. Example, this agent is for server, this agent is for database, another one agent is for, let's say, applications. Alert came, everything is checked at server level, everything is fine. But there are certain logs which are showing the database is not working correctly and tuning is required there. So what happens is automatically the entire context of this agent will be crafted as a prompt and provided to this agent. This agent will going to perform all tasks, and if everything is done, okay. Otherwise, the iteration loop will be there, which will run automatically. I found this thing to be there, but this will be rectified if you change some parameters in the operating system files. Go back. It will do the things. Done again. Loop. Bring it back. I have done that. Can you please check now and do the needful for your database configuration files? So this task will not ask humans to come. They will automatically act, they will automatically plan, they will automatically reiterate themselves until the goal is achieved, the alert is resolved. And then once everything is done, agent will automatically put the updates in the ticket, what all things have been done, and close the ticket, all done. This is the industry impact, and this is where the industry is moving today. Now, very important question. Is agentic AI going to replace humans forever? Right? Humans forever. The answer is no. It will never going to happen. Never. Never. That is the reason you will always see a concept called always human in loop. Human in loop. Without humans, we cannot entirely trust on agentic AI systems because they are automatically taking the decisions. What if they connect to my bank, right? Do all username, password, and do some transaction which I don't want? I am bankrupted. I am gone. I don't want them to do that. There is some confidential report. I don't want to publish it to anyone. I don't want to place it to a place from where it is publicly available. But it is generating data and pushing that data in the database or to the public places where this report is available. I don't want to do that. It will going to ruin my entire reputation in the industry. And so on so forth. There are many use cases where we don't want uh, agentic AI systems to do everything. What we want is we want humans in the loop forever, always. So there are two ways of understanding it. Number one. So I'll start with point number one first. Whenever we are creating agents or agentic AI systems, the first phase of the training, first phase of the POC, first phase of the testing is the place where we should have humans always. Till here. So there will be humans always. They should track, they should tune, they should check what agents are doing correct or not, then again change them, change the logic, blah, 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 blah. So there will be thousands of iterations which are going to happen initially when you are developing agents. Then when 90% of the things are done, this is where what we do is we start rolling out our agents in production, this place. Even when we have rolled out them in the production, it's not that humans are gone out. No. When you create agentic systems, there is a provision where you can put a check mark there. Let's say one agent is there. Very simple example. Let's say this is an agent. This agent is checking the details of an employee, right? And is responsible for onboarding or deboarding. I'm just writing O and D, and doing all full and final settlements, right? All settlements, right? And let's say this is my HR agent. I named it HR agent. Now, until extracting the information, it is okay, right? Onboarding or deboarding, partially okay, not completely okay, because I don't know. Example, let's say deboarding is done, but the laptop which the employee have handed over is not the company's laptop, or that laptop is not in a working condition or good condition. AI cannot check that, right? It cannot log in into your laptop and check those things. No. Such kind of use cases, you need to have human in loop. Another thing, where absolutely mandatory, settlements. Settlements are done, but you need someone to verify those settlements and approve to pay, do the payout. Otherwise, what if there is one extra zero, right? Let's say the payment needs to be done for 1000 USD, and there is something which is extra, one more extra zero, it will be 10,000 USD. Such kind of errors are pretty common. So we don't want to perform such kind of errors. We don't want to give the autonomy to agents to perform such critical tasks. This is where you are always going to have humans in loop. We always want humans to be the checkpointers here. So once agent have completed all thing, reasoning, planning, everything is done. Before acting, we want humans to come and approve, check everything, validate everything, and then approve. Right? This. Another thing is when you talk about creating the logic of agents, connecting it with multiple tools, you need humans. It will not going to happen automatically. You need minimum level of coding which needs to be done for developing or crafting your agents. It's not that I have taken LangGraph, I have used ChatGPT, I will just bundle it together and everything will work. No. Who will going to integrate with these tools? Who will going to fine tune that? Who will going to keep them updated? That is where the humans will always be in the loop. Always. Right? So this is the entire journey from AI to ML, ML to DL, DL to Gen AI, Gen AI to LLMs, LLMs to RAG, RAG to AI agents, and AI agents to agentic AI systems. And when we talk about agentic AI systems, we are talking about autonomy. We are talking about independent, goal-oriented agents or machines which are performing end-to-end tasks for us. Before we jump into a demo, I'll take 2 more minutes and I'll just explain few terms which are very important. Because many a times we are going to get confused with those terms. When you talk about agentic AI, there is a workflow which happens. So the workflow, the cycle, in fact, I would write cycle, how they work. So the first step is perceive. Perceive means taking information. This information will come from multiple sources. It can be tools, it can be LLM, it can be anything. So information is required. Example, that HR system. Now, Yogesh have said, can have just written a prompt. Can you tell me how many leaves do I have? But some information needs to be generated, right? Who is this? Who is Yogesh? Is he a part of the organization? Do we have employee associated with him? Do we have the email address associated with him? His user is created in the HRMS or not? Such kind of information is called perceive. So we take the information. Once that information is taken, then the agentic systems will going to do the reasoning, right? Reasoning means, okay, what he want? He asked for this. He asked for this. He's asking for leave. So they reason. And this is primarily where LLM will do the things. So your LLM should be a perfect LLM for, correct answers, absolute correct answers. Once reasoning is done, now we have, okay, he is the employee. This is the ID. His user ID exists in the HRMS tool. He is asking for the pending leaves he have. Once that is done, the plan will be created. Planning. This is where your agents and LLMs will come. The logic will going to get implemented from this plan. So plan is, okay, I need to go to this tool. I need to connect to this tool. These are the credentials of connecting this tool. This is the employee ID. I need to extract the information of this ID, and the leaves part I need to find out. So all planning will be happen in this cycle phase. Once plan is done, the acting will come. Acting will be done by agents. So agents will execute those plans. So agent logic is to actually connect to a tool, find out the information, bring it back and send it to LLM. And once acting is done, there will be two things which happens. Number one, the result output. So you will get the output, your work is done. So this employee who is Yogesh got the information. I have 4 pending leaves, all done. But here improvement is still left. What happens is the last part will come, the learning. What will happen is you are going to have external tools. You are going to have external databases, which are called vector databases, specifically designed for storing the embeddings, storing the meanings, not rows and columns. These are special type of databases which are created for agentic systems or agents. So whatever summarization crux of this interaction is there, it will going to be here. So that if this is required in upcoming prompts, it will be actually going to be taken from here. So whatever mistakes are done, those mistakes will not be performed again. Those steps, those plans, everything can get stored here. And this learning will actually going to give the velocity, agility, speed to your incoming prompts or incoming requests. So this is how it works. That's the reason sometimes we say PRPLA. This is the term which we use. Perceive, reason, plan, learn, act. Although this used like this. But when you talk about terminology, it's written as PRPLA. So we are perceiving, taking information, reasoning, we are planning, we are learning, acting, and we are learning. This is how this entire thing works. So we learn it like this. This is how the workflow, the cycle of agentic, autonomous agentic AI system works. Now, what we will do is we will quickly move to one of the demos, because this is all theory. We understood it. We know how this works, although it is fundamentals, but yes, we need to have the demonstrations associated with it. What I'm going to do is I'm going to create the weather agent entirely from scratch, right? The purpose is we will write it from all code. So we are going to do the coding and we are going to see the complexities here. And then we will move towards other demos where what we will do is we will reduce this coding and we are going to use other frameworks and tools. Example, the second demo, I'm going to use something called small agent. Same agent, same weather agent. And we are going to use one lightweight framework called small agent. Here we are going to code everything. Logic will be entirely written by us. Let's say we wrote it in 100 lines. Then we are going to use a framework wherein we need not to write the entire logic. That logic will be magically, automatically handled by these frameworks. And we will see it will actually going to reduce our code by 90%. So we just need to code 10 to 15 lines, all done. Then we are going to take this to a next level. We don't want to do a coding. We are not coders. We are actually going to use something called low code, no code. So I'm just writing no code here. We will understand what is code, low code, and no code in the upcoming concepts, but just setting the expectations here. This demo, we are going to do everything of our own. This demo, we are going to leverage small agent framework, which is Agentic AI lightweight framework. And then in the third one, we are actually going to use something called a platform. And that platform, we are actually going to create a weather app or weather agent or weather agent agentic AI system. And here we are not going to write any code. We are just going to do drag and drop, all done. Some information is also required here, like credentials, connecting with tools, giving information of sending the emails and so on and so forth. But you need not to write any Python code here. No. And then we will take this entire ecosystem to a next level, which is called multi-agent model. Multi-agent. And we'll talk about frameworks like LangChain, LangGraph, Zyper, CrewAI, and so on and so forth. And this is where we are going to take this weather agent to a next level. We are going to have multiple agents. Check weather, check flight, do optimization, book my tickets and give me the entire plan. All this thing will be going to be a part of it. And for this, we are going to actually use a low code. Means we are going to do some coding. Because when you talk about multi-agent complex systems, definitely you need to have some coding needs to be done for the logic of our ecosystem. This is where we are going to use. So these are the different demos which are planned. So let's quickly get started with the first one. Now, when we talk about the first one, it's very simple to understand, but very effective. You may use the same concept analogy to other ecosystems as well. Now, what will going to happen? Let's say we have a user and he is planning to go somewhere, but he want to check a few things, few weather things for that. So what it will do is it will actually going to give the input prompt. That prompt will going to go to your LLM. In our demo, we are specifically using Google Gemini. And then this LLM, we are going to connect with tool. This tool is nothing. This is any weather application which is having real-time details. The APIs are exposed. So in here, we are going to put the details of connecting with weather app and doing other things. So what will happen is prompt will come. Example, can you tell me what's the temperature in Chennai? Do I need to carry a umbrella today? This will come. The entire thing will going to get started over here. So LLM will going to find the context here for us. And context will going to be city, let's say Chennai, umbrella, and such kind of things. And then what it will do is it will actually going to connect to this tool and going to put those context here. Weather, Chennai, right? And let's say India. It will going to find out those details, right? And then those details will be sent to this LLM. So these are the output in JSON format, right? So query for thing set here. The output will be sent here. So now LLM is having the input, which is the text. It is having the output, which is the JSON format. It will going to combine this output, this input, and it will going to generate new text for us. This is what they are best in, right? Creating the content. So with this content and this content, what it will do is it will mix it all together and it will say, yes, let's say it's 10 degrees Celsius in Chennai and it seems to be rainy, so it's better to have umbrella today with you. So it will actually extract all those details and going to give that as the response to us. This entire from here to here is nothing. This is your agent, your weather agent. So we have created a weather agent, which is leveraging LLM, which is connected to tools. See here, it is leveraging this. It is connecting to tools. And what we will do is we will write this logic there. How to connect to a tool, what to check, what to bring back, and so on and so forth. So this is the logic we are going to write it here. So in very simple layman language, see here. So we have LLM, which is for reasoning and generating the text for us. Then you have this logic, which is used for planning and which will use for acting. And this is the source from where the data, the actual data will going to get collected. And then all this entire framework is handled and we are going to get our answer. We are not using any agentic framework here because I just want you to see how we create codes or agents from absolute scratch. So we are not using any framework here yet. It's just one of the um, hard way of creating agents, right? So we need two things here. So number one, we need the API for Gemini or whatever LLM you use. And second thing is we use this. So second thing we use is the API key for whatever weather app you are going to use. These are the two things which are required. Let's do it. I'll come back. So this is, I'm going to do everything here, live. So if there will be issues, let us see how we'll handle them. So what I did, I created this demo one. So if you see here, these are the prerequisites. So if I copy and cat these prerequisites, we are going to get all details. So I'm not going, because I'm going to do it on my laptop. It's not a server. So I'm going to create a virtual environment of Python first so that everything happens in that virtual environment. And then I'm going to activate that virtual environment. Now, when you talk about this agent, this is the first agent. We have certain libraries which we need to install. For environment variables, we need .env, and for Gemini model, we need Google Generative AI. So these are the two things which we need to do as a prerequisite. And the third prerequisite, which I already stated, we need LLM API, which is Gemini API, and we need the weather API key. How to get that? If you go to aistudio.google.com, I already pasted this link. You can create your free account and you will get enough things to interact with the LLM and different model details also. Second is I'm going to use this openweathermap.org. So you can also create the account here and you will get the API, right? And they give certain tokens per day. So if you are doing any testing, I think that's enough. You need not to pay anything to anyone. So for this, I'm just going to leverage these two, LLM and my open weather map API. So if I come back to the coding part and I just do more to this weather agent.py. Now this is very simple. If you see here, we are importing certain libraries, right? And loading the environment variables and putting the Gemini and open weather map key, right? And once it is done, if you see here, we are using the Gemini model. So when you talk about Gemini, there are different models in that, right? There are multiple models. Out of them, I'm using Gemini 2.5-flash model. So you can check other models, and basis on your use case, you have to compare which model suits your requirements. And then when you come down here, this is the logic. See here. So what we are doing is we are extracting the city name from the question. That extract the city name, and we are giving a prompt here. See this. User set this question and see here, your job. We are defining a job here. You need to extract the city name. If city is not mentioned, return none. So we are actually this is called prompt engineering. So the prompting is one of the paramounts of building efficient agents. Come down and then we are putting this in the response. And then what we are doing is that city, we are defining again one function and we are giving that city to api.openmapweather, which means automatically or programmatically we are coming here and we are actually searching, let's say Delhi. So whatever we are doing with GUI here, we are actually doing that using API. So city is extracted, that city is passed as a context to the next string, this one. And then the final output is extracted. And then if you see here, we are crafting a good response here. So we are saying user have asked a question, You have a raw data which we have extracted from here, the JSON format. Now write a natural, friendly human answer. Use temperature in Celsius from the JSON, which output you get, and do not show JSON, just 3 to 4 short sentences maximum, all done. So basis on this prompt, this data and user question, this place will be merged and we are going to get the final answer. But there is one more thing which is important. And that important thing is here. We are saying if any user is prompting anything and there is no city in that prompt, in that input, there is no city, then this agent will not going to work, right? Because it's a weather agent. You need to have a city name with that. Now what we are doing is we are saying uh, if there is no city in the input, you should respond this. I could not detect any city in your question. So please tell me for which city you want me to extract and provide you the weather. And one more thing which we have extra done here is when user is prompting, until he is not writing exit, the prompt should not exit. And we are putting everything as an environment variable. If you come here up, we are not hard coding our Gemini and open weather map keys here. So what you need to do is you need to create something like this. If I do cat, this, or let me clear a screen and then do cat, see here. Gemini and this key, these two are required. What I did, I created env file, .env file, this one. And in this file, I have given my Gemini key. I cannot show it because if it get leaked, I need to recreate and delete it. And that is used in some of the internal agents. And this key. So these two keys you need to put. I have kept it here. It's my internal local laptop, so it's not exposed anywhere apart from my laptop. Then we will do this prerequisite first. Let's implement it. So I'm going to create environment this one. So instead of demo one, I'm going to do demo two because demo one is already available here. I tested it yesterday to just make sure it worked. So I'm just going to create demo two virtual environment. Once done, I'm going to activate it. So I'll copy and I'll activate. To done. As soon as I activate it, you will see the prompt got changed. So now we are inside the environment, inside virtual environment of Python. Now, if you see here in the code, if I do cat weather agent py, there are two libraries which we need. One is .env and one is Google generative AI. So this is something which I need to install as pip. That is what is written here. See this. Pip install this, enter, and it is getting installed in this virtual environment. And secondly, I need to install this one. Enter, done. Done. ls python space weather agent, enter. If everything is okay, we should be able to see a prompt. See here, this generative AI, okay, yeah, I think it is getting replaced with Google Gen AI. So if you see here, all done. As soon as I run it, this is asking me a prompt. User will going to give a prompt. You can have a front end to it as well. It's completely up to you, right? So I'll say, can you tell me the weather of Delhi? Should I wear a raincoat today? As I will be out from 10 a.m. to let's say 9 p.m. So this is my prompt. If you see here, this is my prompt. This is what I'm doing. Let us see what will happen. Enter. As soon as I do enter to it, it is actually performing all this thing. Checking the context, putting city as a context, going to tool, fetching the details, getting the JSON output, giving it to LLM. LLM is combining the input and the JSON format and giving me the answer. If you come down here, see this. Hello. In Delhi, the current temperature is 18.05 degree. Right? So you don't need a raincoat for your outing. You might want to consider precautions for the smoke though. So if you see here, it went and it is not out because we have written in the agent and the logic, Until we don't put exit, it will not go out. So if you see here, we are going to get our agent is working. Simple, right? Whatever we understood, it's there. So this is where we have reached, right? Now let's proceed further. Now what we will do is we will actually understand another very important thing, and that is called the agentic AI ecosystem. So when we talk about agentic AI systems, there are three things: foundational models, supporting tools, and frameworks. And they have different purpose and different pattern. Although we understood at a very high level, but let me explain it here again. This is the foundation of agentic AI systems, right? So this is agentic AI ecosystem. There are three things, only three things. So when I talk about, if I write here as agentic, if I write here as agentic AI ecosystem, then there are three things which are absolutely required and mandatory for your agnostic and autonomous agentic AI systems or applications. Number one is frameworks, or let's say number one is foundational models. Foundational models. Whenever we are talking about models, we are actually just talking about LLM, large language model, which is used for reasoning, which is used for perceiving. All that part is taken care by LLM. It completely depends upon which LLM you want to use. There are multiple LLMs which we are already aware of, right? We already spoke about OpenAI, which is nothing, which is your chat GPT. Under the, this is a company. Under this there are models. Let's say you have GPT-5, which is the latest one. You have GPT-4 mini or 4o as well. These are models. Similarly, you have LLM, which is Gemini. Under Gemini there are different LLM models, right? You have the one which we have used. If you see, we have used a flash model. If you go up here, if I do cat, let me do exit, come out, cat, weather, agent. If you go up, you will see we have mentioned this Gemini 2.5 Flash. It means we are using Gemini or Google as a company, and there is a model called Gemini 2.5 Flash. So this is the model we have used here. So you have 2.5 Flash Gemini. I'm just writing G 2.5 Flash, right? This is, you can have what you, example, you have your own LLM models, you can use them, or you can take these models and you can fine tune them as per your expectations, but you need to do that. So you need to have LLM for agentic AI. All text generation, all reasoning, coordination, it happens between LLM and agents. Then comes supporting tools. Now you are creating an agent. You want that agent to do tasks, to do work, to achieve goals. Example, weather agent, example, HRMS agent, example, customer support agent. So they have a goal associated with them. And when you talk about goals, they, you need to connect them to external tools, right? Example, for HRMS, you need to have HRMS tool. You want to send emails, you should have email as a tool. You want to send some details on MS Teams, Slack, so you should have messaging tools. You want to extract some information from the databases, you should have DB. Example, Postgres or whatever. Likewise, you have n number of tools from where you want to extract the information or you want to trigger something out of them. So what you want? You want to integrate with them. Your agent should be integrated with them to perform that task. That is how the automatic work will going to happen. Apply a leave, send the emails, And there is very good use case here. I was discussing it few months ago with one of my colleague. Now, let's say there is a new project which is coming, new project, and that project need the initial discussions or planning to be happened between three teams. Let's say application team, let's say cloud team, and let's say DevOps or automation, let's say DevOps team or containerization team. Now, let's say the manager of application team wants to set up a meeting with cloud team as well as containerization or DevOps team. Now, the traditional approach is he will going to check with the person of this team and this team, find out when they are available, a common time, and then we're going to schedule a meeting and follow up. Now, what you can do is you can actually replace this entire cycle with AI agents or agentic AI system. You just need to tell this person, again, to agent, you will give a prompt. So let's say Yogesh from team C and Mahesh from team D. I want them to have the discussion because a new project is coming. So check their calendar, book everything, and do a follow up until the meeting gets scheduled. You just give this prompt. Automatically, the agent will going to check your timing, right? When you are available, when this person is available, when this person is available, we're going to find out a common time. Basis on this common time, it will automatically, because it's going to have access to your calendar, it will automatically going to book the slot, and it will automatically going to put the reminders for the meeting until the meeting is getting completed. You need not to do anything. You just need to write one prompt, all done. This is the power of agentic AI. It's not only crafting emails like we do in generative AI. It's actually achieving a goal. So this is a goal, and we are achieving this goal with almost zero human intervention, right? But you need to have integration with email, integration with your calendar, integration with your teams and other tools. Those are called supporting tools, right? So foundational models, which are LLMs, supporting tools with which you want to do the integration to achieve a goal. It's a goal oriented approach. And then what you want is you want this entire coordination to happen. You want the entire communication to happen. You want the automatic planning, reasoning, and action to happen. This is where what you do is you introduce something called frameworks. Frameworks, right? You have a logic which is there in the agent. You have supporting tools. You have LLMs, but you want a coordination to and fro, from here to here, from here to here, from here to here, from here to here. Coordination, communication, right? So you want the orchestrator which can orchestrate this entire workflow. This is called workflow. You want to orchestrate this entire workflow. That is actually being taken care by the frameworks, agentic AI frameworks. And when we talk about agentic AI frameworks, now please put utmost attention here because it is very important topic. Usually we get confused. Why agentic AI? If agent is doing everything. Agent is the brain. Agent is doing a logic. The coordination, communication, all such things, the orchestration is being taken care by your workflows or work frameworks. Now, when you talk about frameworks, there are different type of frameworks. Let us understand that too, right? There are different type of frameworks. So I'm just writing agentic AI frameworks. Usually they are categorized in three different categories. Number one is called code. Number two is called low code. Number three is called no code, right? Code, low code, no code. Code means you need to write the entire thing yourself. Entire thing yourself. It can be creating agent from the scratch. Absolutely, like the way we did. It can be using some frameworks or libraries where you need to write less code, but still you need to write a code. Example is small agent. This is a framework. There are many other. Next is you want to, now here you have full flexibility. You do whatever you want to do, but you need to write hell amount of a code. I don't want to do that. What I want is I want minimal, not minimal, I should say I want moderate type of coding, not entire coding. I want flexibility to write my own logic or tweak the logic, but I don't want to write everything from scratch. I want some predefined libraries, predefined modules which I can leverage. This is where low code will come into a picture. Now, when you talk about low code, this is very famous because majority of the agentic AI framework innovation is happening here. This is where multiple companies have developed their frameworks. The first one was LangChain. This was the first low code framework which was used by the organizations. Although it is not highly production oriented, but it give all the basic things for linear agentic models. One to one, one to one, one to one means one task, then another task, then another task, then another task. This is for linear approach. But the use cases are complex. Linear approach will not work. Check my leave, apply my leave, linear. Check my leave and then calculate my salary. If I take two leaves, how much salary I am going to get? Complex. Such kind of things, there you want graph. You want logic. If A and B, not A and B like this, it's A and B, and then go to C. Such kind of complex logics are little difficult to attain in LangChain. You can do that, but complexity is more. That is where they created and gave another framework which is called LangGraph. So what you do is you create the orchestration in a graph mode. And then graph mode, do this, go here, do this parallelly, and all that kind of a framework which it gives and works with. But when you talk about real terms, again, when you do little research, you will see LangGraph and LangChain, they themselves say that use with precautions in production. And that is where opportunity for other frameworks or companies, came in. And that is where the opportunity is taken care by a company called CrewAI. So there is something called Crew framework, CrewAI, that is like LangGraph, but it can provide multiple things. So you will have one orchestrator, which is called Crew Orchestrator. Then you can have multiple crew agents, and agents will be having tasks associated with them. And then there will be multiple tools, LLMs, and other where you are going to connect. This is one of the examples we are going to use at our last demonstration. We will going to create a multi-model agent using CrewAI, right? But this is low code, means you need to write code here. Now that code will be not entire from start to beginning, but yes, you need to code. Then came another term which is called no code, or sometimes we say low code, no code, right? So we intermediately use this term, low code, no code. So when you talk about no code, what we want is we don't want to code anything. We want one canvas type of a thing like this blackboard, and we just want to do drag and drop, plus button, minus button, delete button, change button, and etc. etc. Right? So we want a DAG based ecosystem where we drag and drop. This is where other tools came in, but they are not free, they are paid. So the first one is n8n. Very common, very famous. You will see many people are talking about it. n8n. Another one is which is by OpenAI. So it is OpenAI toolkit. It is by OpenAI. In fact, I think there is from Microsoft also. It's called Microsoft Power Auto or Auto Power. It's Microsoft Auto Power or Power Auto. They also have one such tool. Here, what you need to do is you just need to drag, drop, do this, do that, and all stuff. And at the end of the day, our entire agentic AI solution will be done. Entire solution will be created, all done. Right? So depending upon, now again, decision. The question is what to use. The biggest question is what to use. Let me change a different color notation. What to use is a big question. It depends upon multiple parameters. The biggest parameter is cost. So when you move from here to here, cost will also increase. The biggest parameter is cost. Here cost is less. Here cost is okay. Here cost is highly involved. Right? Flexibility, cost, flexibility, and the capability to do or craft your own logic. All such things will depend upon either you are using a code-based approach or framework, low code-based approach or framework, or no code-based approach or framework. That will completely depend upon different organizations and how they want to leverage or use the things. Right? Super. What I will do now is we have already used this approach, this demo. Now, same demo I am going to create using this, and I will show you how drastically the things will going to change. Here, if we were having, let's say 100 lines, what I'm going to do is I'm just going to have, let's say 10 to 15 lines here. Import OS and all those libraries. I am not going to, just going to import the libraries of small agent and with which tool I want to connect. That's it. Nothing else. I just need that. So what I'm going to do is I'm going to use small agent now, right? Let me go back, and let us come here. Before I jump here, if you go back, I already given this link. So Hugging Face is a platform where you are going to see multiple models, multiple frameworks, multiple things. So small agent is a part of this platform, Hugging Face. So this is the documentation. If you come down here, you will just get all the details. So there is something called small agent. It's an open source Python library designed to make it extremely easy to build and run lightweight agents with few line of code. It's not recommended for production. It's just for learning purpose. What it has is it has something called code agent. Example, if I come here and I do weather agent, this is the code I was writing. If I do cat-n weather agent, so it is 70 line code. So this is what I was doing. Now what this framework have done, this framework have created something called code agent. This is an agent. So the coding, this type of coding is actually taken care by this agent itself. I just need to call this agent, all done. I need not to write something like this. No, I just need to call this agent and it will automatically write the code for me. It will automatically invoke and perform computation, integration with tools, enabling NLP or natural language composability, automatically doing the loops, iteration, nesting, etc., etc. So instead of me, this will going to be my assistant code agent, which is the part of small agent project. You can integrate it with MCP. You have multiple hub integration agents available. You can use the CLI utility and you can go and read about it. So if you see here, you just need to install this library or this Python library. Pip install small agents, all done. And after that, see here, we just need to write this. We are saying from this, I am importing agent and I am importing this inference client model. This is the library via which you interact with Hugging Face, right? And then we are saying, I want this model and I want code agent to check the tools and check the model and give me the result, all done. Exactly this thing I'm going to do. Example, if you come down here, they are using DuckDuckGo search tool. So this is very famous tool, DuckDuckGo search tool. So it is like google.com. So instead of this, I am going to use web search tool. So this is agent. This is your helper, which will going to write a code. This is how the model or interaction with Hugging Face will going to happen. And this is the tool I want to integrate. There are multiple tools. If you scroll down here, you will see this built-in tools. So these all are the tools which are supported by small agent. Information retrieval, web interaction, code execution, user interaction, speech processing, workflow control, and so on and so forth. If you come down here, not down, little up. So they were in the example, they were using DuckDuckGo search tool. Instead of that, I am going to use this web search tool, right? This web search tool. Let me draw it so that you can understand um, what we are doing. So if you talk about the first example, which we have done, it was like this. There was user. We were going to agent, which was actually prompting everything to LLM. So this was our agent, and agent was going to open weather app. Open weather app, right? Or open weather website. So everything was hard coded. What we did here, we have used Gemini. Here we created the logic ourselves. We did that. And this is called tool with which my agent is doing the interaction. And this entire is called Agentic AI framework, simple, or Agentic AI solution. Although partial, but yes. This is first example. Now in second example, we are going to tweak this. Same thing will happen. We are going to have the user. Now this time we are going to have something called small agent framework. Right? Actually, what happens is here you have the framework or orchestrator, you can say. So this here you have something who is a planner. So you have orchestrator here. What he will do is from your prompt, it will actually do the context searching like this. So orchestrator like this, like this, like this. So it will go to small agent. The this is called perceiving. So which tools are there, what all things are there, blah blah blah. So instead of writing this logic, we are actually taking this logic. We are not writing it. We are leveraging which is already written. And this logic or this entire solution is governed or controlled by this orchestrator. This, which is invisible term you can think at present point in time, right? We will make it visible in the next or next to next example. But this is your orchestrator. This is the framework, which is hidden, means it's a hidden function which is running. Then what happens is this is LLM. You can use any LLM. So you need to write inside this which LLM you want to use. We have used Gemini. Let's say here we are going to use the default Hugging Face LLM. Hugging Face default LLM we are going to use, let's say. Then this tool. Now what we are going to do is we can integrate external tool, but this time we will leverage the inbuilt tool, which is this web search tool. It will go to web, search on multiple places with real-time detections, come back and do the thing. So we are going to use this web search tool, which means we need not to write any code here to connect and do anything. So we are going to use inbuilt tool here. So I'm just writing inbuilt tool, which is web search tool. Just understand the context here. What we are doing is, instead of doing everything ourselves, we are leveraging the tools which are provided by this framework. Instead of writing our own logic, we are leveraging the logic which is already written. And then this is your flexibility. You can put Gemini here, you can put whatever type of LLM you are comfortable and you or your organization have fine-tuned. So you can replace this LLM anytime, right? But what we are doing is we are reducing this thing and we are leveraging what is already present. So with this, our code will shrink because we need not to write everything ourselves. The logic and other things which we are writing here is already written here. You can put your custom functions here, but If you don't want to, then you can just leverage this. So we are going to actually use this. So tool, that website is replaced with web search tool, and this agent which we have coded ourselves will going to be replaced by small agent. This is nothing. Actually, there is an agent called code agent, which is doing everything for us. This is code agent, which we are not writing. It is already written. This is the code agent. If you go back, sorry, go here, you will see this code agent. Now let's see the magic. So first thing is I need to install this one. This is a prerequisite. If you go back, I think I would have written that. Cat prerequisites. Yeah, see this. Install small agent library. This is one prerequisite. So let me install it. We are already, if you see here, if I do enter, we are already in the Python virtual environment. So I'm just going to do this pip install small agents. I am installing this framework or library. Framework is nothing at the backend, it's a Python library. Once it is done, then what do you need is you need to have this. This is Hugging Face. If you see here, huggingface.com. So you can create your account and you will get a free API to interact here. Although specifically it is not mentioned here, to interact, you need to, for this agent, you need to have the API key. But if you don't give it, it will throw you an error. So you need the API key for this, which I already have. Right, so you can just come here, go to your login, you will see API there, so you can extract that API. In my case, I'm already having that API, and that is the reason. If you check environment sample file, I have written HF. H means Hugging Face token. OWM means Open Weather Map API. Gemini key means the key for LLM. So in my env file, if I do this, it's already there. Right, next thing what I need to do is I need to code it. So I have, if I show you this code, enter, this is what you have to write for the same thing which we achieved in the previous demo. If I do cat -n weather and I do small agent, see here 1 to 14 and one line, 5 lines are less, so this is just a 9-line code, all done. Same thing it will do. What I did, see here, I use their logic. I'm taking their agent, I'm taking their inference client model to interact with Hugging Face API, and I'm using their tool called web search tool. And what I'm doing is I'm saying model you have to use. Now if you are not giving any model, this is empty, it means it is using Hugging Face model. So it will going to use by default Hugging Face model. If you want to put your own model, you can put that, and you need to put a key also, API key. Then I'm saying agent will going to be a code agent, which is already pre-built logic. And you have to use this tool. And the model is this one, which is a default one. And I want you to stream the outputs, means show me the output, what you are doing. And then I'm putting some custom logic here, which I have used in the above. If I go up, here also. If there is no city, show me this. Or if you see here what I'm saying, the user prompt should remain until he is saying exit. And then finally print me the results. Everything, perceiving, reasoning, planning, action automatically going to happen here. So the entire cycle of agentic AI framework you will see live now. What I'm going to do is Python, whether small agent is. Let us see. User, what should I write? I'll say, can tell me the weather in Paris. Shall I take umbrella and raincoat? Enter. See this. If you see here, this model, the request is going to this model. This is Hugging Face model. See here. Tell me the weather in Paris. Shall I take this? See here. This is the step 1. Inference client model. This is what I have written here. This is to interact with your Hugging Face. Let us go up, see this. Then step one, see here. I need to find the current weather in Paris. Automatically see this line. Thought. This is something with the context LLM have created this thing for us. Our prompt got converted into this prompt now. See here. I need to find the current weather in Paris. So to determine if an umbrella and raincoat are needed, I will use the web search tool to get the latest weather information. See here, step one. And what it did, web search, automatically the code is getting written here. See this, right? This is one line of a code. This is another line. So print this. If you see here, executing search logs, it went to this website, this website, this website, this website, and multiple other websites to uh, extract the temperature. If you come down, see here, step two. The search results for current weather in Paris mention terms like chance of this, chance of this, chance of this, blah, blah, blah. This indicates that rain is expected. Therefore, it's advisable to take an umbrella and raincoat. See here, final execution, final answer. Yes, this. So this is passed to your LLM. And then see here, the final output, final answer. Yes, there's a chance of rain in Paris. Take an umbrella and raincoat. See here. Super, right? Same thing. And because it is agentic framework, so you will see everything. It is taking the information, it is planning things, it is acting on that thing, and finally it is crafting a beautiful output to us, which is human readable. Now, if you see here, the prompt is there. So until I do exit, the prompt will remain. This is what I have written in the code. Whether, let's see here, exit. Now, let me clear the screen and we'll come to the next part. We have seen how beautifully we have shrinked the code. Although it is just a glimpse, right? When you go to production, there will be bigger code, let's say 1,000 liner, and then we are going to convert that into, let's say, 100 or 150 liner. Still coding is required. Now we will come to the third example. The third example will going to be no code. Now I want a GUI. Same example we will do. So this is our own. This is using small framework. And now this is using no code. We are going to use n8n for this. It is GUI actually. It's a graphical user interface. We are going to just create something called workflow. And then we are just going to click on plus button. You want to put agent, you want to integrate with tools. Those tools should have a memory or not, with which LLM they should get connected. What is the prompt you want me to give, and so on and so forth. So you just need to do this and you need to just execute this workflow, all done. So when I was replicating this demo, I tried the same demo in n8n yesterday so that I can, take the same demo and show the details to you. We are going to do it from scratch, don't worry, but this is going to be our next demo now. And for that, you need to go to n8n. See here, this is the dashboard. This is n8n dashboard. And if you closely see this, there is something called workflow. Yesterday, I was replicating the same thing and I created this one. If I click on it, just to show you how it looks like, it just looks like this. See here. You are going to give a prompt. Prompt will go to AI agent. AI agent will going to have chat LLM for reasoning and planning. And then if you see here, there is open weather map. We just do this and you execute this. If I go back, if I show you, not here, where data table, very executions. If you see here, I ran it 3 times yesterday. 12, 10, 12, 11, 12, 11 with different parameters to see what context and what kind of answers it is providing. Is it same or not, and so on and so forth. So if I come here, I think from here I can open it. Yeah. If I just click on again, little confusion. If you see here, you come here, then only the pop-up will come like this. So you click here and you will see the result here. See this, what happens, how much time it took and blah, blah, blah. So if you come to evaluations, right, not here, editor. I just want to show you something. Executions. It is populating. See here. This is exactly what happened. See here. I was asking, tell me about a cricket match today. See here. I'm sorry, but I can provide you the information of weather only. So I was doing a fine tuning of it. That if any other question come, it should not give the answer to it. See here. So if you ask anything, okay, tell me about this movie or tell me about this particular place, tell me about this restaurant, it will not going to give the answer. We fine tuned it in such a way, if anything apart from weather or city is coming, it should be rejected there. See this. So you will get output like this. I am sorry, but I can only provide information about weather. And if you come here, this one, you will see a different answer. See this. This is the prompt. Can you tell me the weather in Delhi? Shall I carry a jacket today? See this. It give me this. The weather in Delhi is this, blah, blah. See here. This is the output you will get. So LLM will going to craft it and give it to you. It's this. It's quite mild, so you likely won't need a jacket today. So what happens is, see this. Um, Let me bring it a little up. And here. The one which we understood. What happens is, as soon as you give a prompt, it will actually going to go to your AI agent. AI agent will going to interact with your Google Gemini. Means it will going to interact with your LLM models. If I click here, you will see it. What happened is whatever prompt is given here, that prompt is changed. This is called system message. So we have given system message to restrict the things. So the user message and the system message is clubbed together. And then it went to your open weather map. And see here, what happens is it extracted the context. If you see, this city is a context. City is Delhi. Then from this weather map, see this longitude, latitude, weather, ID, blah, 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 temperature, feels like, minimum temperature. This is the JSON output. This JSON output and the initial prompt and the system message is sent back to Google Gemini. See this system message and see here user message. I am in Delhi. See this. This is human. This is user message. This is system message for doing fine tuning of the results. And if you see here, this is the output sent by the tool. These three are sent back here. And then text generation comes. It will combine this all together and give me a beautiful result like this. So agent will give this result back to me. The weather in Delhi is currently hazy with a temperature of this. It's quite mild, blah, blah, blah. You need not to write any code for this. You just need to draw a diagram like this. Let's do it actually. Let me show it to you. This is workflow. If you see here, there is something called create a workflow. I'll copy to it and see here. I'm just going to get this. Your first step, right? You just click here and you will say trigger it manually. So there are multiple things. You can trigger it using webhooks. You can schedule it. Someone is submitting a form. Example, you are taking the feedback from your employees and you want to create or do something out of it as a goal oriented. So you can have form submission also. Chat message you can integrate and so on and so forth. So what I'll do is I'll trigger it manually. Click. Then you will see there is a plus button, right? So I need to double click it to trigger it. So there is a plus button. So I'll click on this plus. What do you want to do? You want to build autonomous agents. Autonomous means we are talking about agentic AI. Wherever you see this word autonomous, it means agentic AI. You want to create a flow. You want to create a human. See here, human in loop. Wait for the human's approval. This is what we were discussing earlier. You want to do data transformation. There are multiple use cases to it. I just want to create an agent, weather agent. So I'll click on this agent. See this, which type of agent you want to use. See here, AI agent, Anthropic models, Gemini models, which models do you want to use, blah, 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 blah. These are called agents. So I'll just say I want to use AI agent. Now, if you see here, source from prompt. So whatever anyone is going to put in the prompt will going to be the input to this particular agent. If you want to do a fine tuning, what you need to do is you need to put what you want to restrict. See here, you can put maximum iteration, return immediate steps, automatically pass through some images, streamline batch process. What I want is I want whatever message user is giving. On top of that, I want something to put so that restriction can happen. Example, if it is weather agent, it should not give you what's the details about a particular restaurant. So what we will do is we will put an system message here. Example, you write something like this. You are a weather agent. We are setting a context. You are a weather agent, right? Your role is to find the actual weather details for any city in the world and suggest necessary precautions. This is one thing. Another thing I want to say is make sure to write a natural, friendly, human answer. This is second thing I want. This is called prompting. And I'll say use temperature in Celsius only, right? Do not show, do not show JSON output, right? Use 3 to 4 short sentences, right? For answers. This, and I want another thing. If the user is not providing this city name, then answer back politely, stating, please provide the city name to me to check the weather. Apart from weather, do not entertain any other answers, but respond back politely. See here, this is called prompt engineering. See this. These are many shots. So I'm giving many short descriptions to make sure what kind of answer is coming, what type of output you have to give, where you have to put the restrictions, and so on and so forth. Once this is done, right, you just close it. You will see your AI agent and you will see this question mark. As I said, AI agents, you need to have the chat model and you have to have the tool associated with it. Even tool, if you are not giving, it's okay, right? But as we are creating a weather agent, we need to give a tool for actually agentic system. So if you see here, it is saying chat model. So click here and you will see different models are there. Example, I search for Gemini. Gemini, see this. Click and it will ask you to actually create, give your API key here. So my API key is already available here. So I need not to give it, but you need to give it for the first time when you do it. So you need to create and you need to give it here. So I have already put my keys here, right? Because I don't want to copy paste it explicitly here. Go back, see here, it is connected, right? So this will going to perceive, this will going to reason, and this will going to help in planning and definitely going to give the good created outputs as well. Now what I want is I want tools, right? Tools. So I'll click here. There are multiple things which are already available here. See this. You can put your custom tools also. There are multiple things where you want to connect. So that is the reason we say no code. You need not to code anything. But if you want to put anything, uh, a tool which is not available here, then what you can do is you can use this code tool and you can write a tool in JS or Python to integrate. Here I'll just search weather. And if you see here, there is open weather map. And this is what we have used earlier also. Let us use this. It is again asking us to give the details. See here. So already the credentials are available. So it have taken that from my account. Now, if you come down here, you will see this city and language. If I save it, it will show me an error. So what you can do is see here, you can do this. Let model define the parameters. Click here automatically. Language, English. So you need not to put city name and all and all and all things. No. Once done, close it and you will see that exclamatory mark is gone. Now let me introduce another thing which is important. I haven't introduced it earlier because it might create confusion. If you see this memory, this is very important term to understand when you talk about AI agents. Now, when you talk about humans, if I ask you what happened 2 days ago, you have the memory for that. If I ask you, okay, can you tell me the last marriage you attended? Do you have some memories? You will say yes. You will go in the past and you will bring the memories back, correct? Same thing when you talk about AI agents, they are stateless in nature by default. They cannot remember anything. They cannot. Which means if one task is coming 10 times, it will going to do that task 10 times from step 1 to step 10. It will not going to use the memory or because it's not having memory that I have done this in the past, this is the answer to it. It will calculate everything from the scratch. To mitigate that, because it will impact your performance and you will not be able to use, you know, autonomous agents in stateful applications, right? Because they are not having memory and stateful applications, you need a memory. That is where your memory will come into a picture. Memory means we are integrating it with databases. It usually it is vector database. You can have Pinecone, you have Milvus, you have FAISS, or even if you want Postgres, you can implement that, but certain features will not be available. For cache, you can use Redis. For data storage, persistent data storage entirely, you can use S3 also. If you click on this memory, you will get those options. It will make your agent to work for stateful applications also. See this. So you can use MongoDB, you can use Motorhead, you can use Postgres, you can use this, you can use SATA and all. Or even you can use this one also. Store in n8n memory, so no credentials required. It is like a cache, right? I'm not using it, I'm just showing you, right? So you can actually add this also. And you can add multiple tools, tool here, multiple tools, right? But LLM is one. And then if you want multi-agent, you can add more agents also. I'm not adding it. We are just doing it like this. And then what we will say is we will say execute flow. So it is saying no prompt specified. So we need to give a prompt now. So I'll go up, up, up. This is the prompt. Now, let's say we will use same prompt is okay. Tell me the weather in Chennai. Do I need to carry a jacket? Yes. Right? And I will say enter. As soon as I enter, see this. What happens is tell me the weather. This is your trigger. This is your actually prompt, right? When chat message received. So this is your prompt. It went to your AI agent. See this. And then what happens is AI agent went here. Now reasoning is happening here. If you see this two means two times LLM is used, right? Twice. First is whenever request came, that request went to your Google. Here, agent redirected it to your model, which is LLM. And when you see here what it did, if I just open it, you will see what is happening. It is combining two things. One is the input of the human. If you see here this, tell me the weather in Chennai. Do I need to carry a jacket? And then this is the system message. See this. The fine tuning which I did. See here. You are a weather agent, your role. So it is combining this thing and setting a right context, right? See here. Once that is done, Then the context, the parameters, the context are extracted, and the connection with the tool happened. See this. And if you see here, it extracted this Chennai. Chat input is this. Session ID action is send message, means we have to send the message. See here, tool call ID is this. City is the most important one. Then it connected to your weather map app, and see here it extracted longitude, latitude, ID. If you come down temperature, it feels like blah blah blah, all those things. Then this information is sent back here. So we are having system message, we are having human message, and we are having these all parameters. It is sent back to it. Now what this did, generative AI, it generated a new content out of it and created this output. See here, hello there, the weather in Chennai today is a bit hazy with a temperature of 28.27 degrees. It feels like 29.5 degrees, so it's quite warm. You definitely won't need a jacket. Enjoy your day. Super awesome, right? Everything is taken care by this no code platform for us, right? So this is the third way of doing the thing. So what we did, from here we reached here, and from here we reached here. Right now what we will do is we will actually make or our understanding little more advanced. Right, I will not go much advanced so that it cannot confuse you, but certain concepts are very important to understand, because in real agentic AI systems those concepts are used widely nowadays. Although few permutations, combinations, hidden trials, they are keep going on, but definitely in future, when such concepts will become more mature, definitely companies will going to look forward to that. So let us come back. Here. I will start with the problem first, and then we will find the solution to it. Right? Here. So far we have understood we are having user inputs, right? User inputs. It go to AI agent. Agent is connected to your LLMs, right? For performance and learning, it have something called memory, which is nothing, which is a vector database. And then there are tons of tools with which these agents can connect. I will again going to take the example of HRMS. HRMS. So what happens is in the logic, right? Because it is a enterprise tool. In the logic, what we do is we write the code to connect to this HRMS via APIs, correct? So there will be exposed APIs, and we are going to connect with them, right? This is what actually happens, right? So there is a logic, there is a connection. This is how connection happens. Now there is a problem, right? There is a problem, and that problem is in your logic, you need to write how to connect to these APIs, how to extract the data, format, everything. So this entire logic of connection and retrieving details or retrieving outputs is something which you need to handle, right? And if something is getting changed related to any parameter, related to any APIs, from V1 to V2, they have migrated the APIs, from V2 to V3, they have migrated. You need to recode or change your logic, which is quite cumbersome task, because it is just one tool. Let's say there are hundreds of tools, and you're writing a custom logic to interact with those tools, all connection logics to interact with their APIs. And these APIs you are not managing. These APIs are managing or getting managed by these tool providers. And when they are getting changed, your logic is also getting here and there, right? So you don't want to ripple your logic. You want to segregate this logic with agent logic and connection logic. In this case, your connection logic and your agent logic is in a same code, and you are managing it. You don't want to manage this, because if you are doing it, it will always going to be an infinite task for a lifetime for us, right? This is exactly what MCP handles for us. Model Context Protocol. It handles the connectivity, right, from agent to HRMS tool. But what it do is it do the tool abstraction. Tool abstraction. It's a tool abstraction layer. Agent is not allowed to directly interact with this HRMS tool. No. If you are doing it, then you need to maintain this connection logic in your agent. And I don't want to do that. So to solve this problem, MCP came. And MCP become a hit for many organizations. And you will hear this term. Vendors are creating their MCPs, Docker MCP server, Terraform MCP server, Cloud MCP server. They are creating MCP servers. MCP servers are for standardization, protocol standardization from agent to tool connection. These are protocols for standardization, right? So that this connectivity, you need not to handle it inside a logic. It should be handled out of the box using an abstraction layer, which is MCP. Let me actually show you how it works so that you can have a clear picture, because these are they create a lot of confusion. So the better understanding is always important here. What happens is you use a framework, right? You used AI agents. Same thing. AI agents are connected with your LLM, and they are connected with your memory, right? To speed up the things and for performance. Now, here you are going to have agent logic only. And what happens is you are going to have, there is one layer, this layer. This is called MCP client. MCP client. This is nothing. You need not to have a server and install something. It is not an agent. No, it is something which is included in the agent framework. First thing, don't think that this is a server or this is a container or this is an agent. No, it is just a library which we are calling out of the box using a framework. And we just need to create something called mcp.py. That's it. What happens is how to connect. You are going to have things here. You will write here mcp underscore client underscore connect equal to this. And then your work is done. Your connection logic, you cannot go beyond it. These MCP clients are going to connect with your MCP servers. People often get confused MCP server or host. Actually, this is your either MCP server, or it is MCP host. Right? This is the one which is actually going to make a connection with the tool. So your HRMS tool. Agent will not going to make a connection here. No. Agent is just writing here. Okay, this is the tool where I want to connect. MCP will going to do a calls to your MCP server. And MCP server is something which will going to make the connection, take the output, give it to client, give it to agent, LLMs and all. Now, the good part is if anything is getting changed here from V1 to V2, you are changing your APIs, you need not to worry. Why? Because until this is the responsibility of a provider. Tool provider will handle this. So if there are any changes they are making in their tool or connectivity or protocols or API changes or whatsoever for the connection retrieving data, that is actually, if they are changing it, they are going to do changes here at this place. So at our place, we need not to do any change. Automatically, we are already having everything. So it will actually going to connect here. And then they will redirect from here. It's not V1 now, it's V2. So automatically that change will happen here. And this connectivity with the tool is actually handled by this layer, this. So this is tool abstraction layer. So this is tool abstraction layer. It's not mandatory to use MCPs, but we should be aware of the concept. See here. So this logic is only for agents to perform the task. Reiteration, loops, and all those things. The actual core logic, brain. The connectivity part, now again, if you have other agent or other tool connected with this particular agent, right, you should have MCP client for that. Then you have MCP server, right, where vendor have written how to connect and all this. And then let's say this is some other application, app one. So this is how the connectivity will going to happen. So you can have multiple MCP servers, multiple MCP clients for multiple applications. This is just to reduce the connectivity part. So you don't want your agents to go and do the connectivity and put everything in the logic of connection here. No, we want to abstract that and we want to put it here. This is where MCP jumps in. It's a very important, very crucial term, and hence that's the reason I'm explaining it here. New. Now, whatever we are talking till now is actually called a single agent agentic AI system. We are just talking about a single agent, right? Now, what happens is, let's say you have a goal, right? And you want to create something called agentic systems for them. Agentic systems for them. Now, first of all, what you need to do is you need to understand your goals. What is your goal? Is it just to extract an information, or is it the entire autonomy of one product for me? You need to understand your goal. Once the goal is understood, what you need to do is you need to see how many steps or independent steps are required to perform this goal. Let's say you have one step, you have two step, and let's say you have three step. Let's say I'm talking about HRMS only. The first part is I want to completely automate autonomously the leave system, right? Apply leave or checking leaves and all those things. I want to automate the salary slip process also, right? I want, if anyone is taking a leave, right, or he wants to check if I am going to take two leaves or leave without pay, what salary I am going to get at the end of the month. Calculator, salary calculator. Option number one is I can create a single agent for that. Option number one. Definitely you can do that because they are similar. But if you see here, your HRMS system is different. And let's say this salary, this is here something you are using, let's say fintech. I'm just writing something called FinApp. This is different app for generation of salary slips or documentation or another and other and other. And let's say this is another app called CellCal. I'm just writing salary calculator, CellCal. So you have three tools, tool number one, tool number two, and tool number three. These are the three tools. Now, as a goal, you found that this is one thing I want to achieve automatically, this is second, and this is third. Now comes, this goal should be associated with certain designs. How the flow should work. Either it should be sequential, So first of all, it will check the leaves. Once leaves are done, then it will check the salary slips, and then it can calculate something like this. So this is sequential. But in this case, sequential pattern will not work. Why? Because there are two things which are entirely independent. If you see here, this one, leave. Applying a leave is entirely independent, and applying a salary or generating a salary slip is entirely independent, right? But there is a strong, this is independent. So what I want this design to work in parallel, right? So my agent, uh, my orchestrator should route things parallelly to these two agents. But there is a strong dependency here. Calculator. Someone have to check the leaves first. I want to take two leaves. Two, let's say two leave without pay. Then it will go here and check the calculator and see, correct? How many leaves are left. Basis on that only the calculation will happen, which means there is a dependency between this task and there is a dependency between this task. These two things will always be in sequential. So sequence 1 will be this and sequence 2 will be this. This is called hybrid pattern. So you can have sequential patterns, you can have parallel pattern, you can have reiterate patterns. There are multiple patterns, but that completely depends upon the goal you want to achieve. So you need to do multiple permutations and combinations in order to understand which agentic AI design pattern suits your goal for your agentic AI systems. And then basis on that, you need to actually start developing your agent logic. So there is a very good documentation. I would say you should explore it. I already pasted that in your chat part. If you come here, see this. So you need to understand your requirements, right? You need to see the common patterns of your agents, and then you need to select a pattern. Which pattern do you want to use? And basis on pattern, you need to identify latency, performance, cost. Obviously, the cost will going to play a pivotal role. Single agent system, very simple, which we understood, right? You give a prompt to a agent, it is connected to LLM, it is connected to tools, all done. This is what we are doing till now. But when you have multi-agent systems, like I said, there will be three agent, one for HRMS, one for FinApp, one for salary calculator. In that case, what will happen is you have to choose a perfect design pattern for your agentic AI systems, which you are about to create or about to develop. See here. So you have sequential pattern, means different tasks. Example, go check the leaves, then apply the leaves, and then show me the result. So these are tasks. So these are sequential tasks, one after another, one after another. Similarly, parallel pattern. See here. The request is coming, the framework should pass it to two different agents simultaneously, and two agents will give the answer here, and it will again convert that answer into human readable language and provide the results to us. This is called parallel pattern. Likewise, you have loop pattern. Until the condition is not met, the loop should work. But it create a lot of confusion also, because it create infinite loop. That is the challenge. Come down, you have review and criticize. So review and critique pattern. So one will be a generator, one will say, no, this is missing here, this is missing here. So until the exact scoring is not achieved, the result will not be achieved. Likewise, you have iterative refinement pattern, you have coordinated pattern, and so on and so forth. So I already give this to you, right? So you can check it. But majority of the time, these two are used. Means we use a hybrid pattern of parallel and sequential, right? And this kind of systems are called multi-agent systems. Now, if I draw it, it will be something like this. I go back, and come here. So there is a user, right? This user is giving a prompt, right? So there will be some framework orchestrator available here, right? There will be some framework here. LangChain, LangGraph, right? So this is called orchestrator. I'm just writing framework orchestrator. which will decide basis on this input with which is the potential agent for doing the things, and then there will be multiple agents. So I'm just writing, let's say agent 1. So this is my agent 1. I have agent 2 and I have agent 3. Right? This is the core logic. This is managing the communication, coordination, to whom the things should go. Right? This is connected with your LLM. Usually what happens is we have a same LLM, but you can have different LLMs also. So I am just putting LLM chunk here. These all agents are connected to this LLM. LLM, LLM, LLM. They are connected to different tools. Example, this is HRMS. This is, we created something called FinApp, financial application, which you use in your organization. And let's say this is your salary calculator, CellCal. These are called tools. These are called agents. This is called your model. And the coordination between agents, tools, models, how it should work, that entire coordination and communication is supported by something called frameworks or orchestrators. Right? So I'm just writing communication and coordination. And you can have in between MCP layer in case you want. This is called multi-agent model. Multi-agent model. Right? Now, in multi-agent model, there are two things which are very important. One is called A2A, agent-to-agent protocol, and one is called Strands agents framework. I will bring in Strands agents first. So I will remove this, come here, bring a different color here, and try to explain it. When you talk about the agent, in agents here, right, we write a logic. That logic is which tool to connect, and then how to connect, and then what to do, take this output, come here, plan, blah blah blah, all this. So this logic, right, for every agent, you are going to have this logic, right? Which tool, what is the purpose of this tool, what is the role of this, how to connect it, what to do with this, and so on and so forth. So what happens is we put a lot of logic here. This is actually again, this is actually called tasks. Under logic, there are tasks. Tasks means we code these tasks, that what this agent will going to do. So we do a coding of these tasks, multiple parameters and multiple things, right? Python coding, we do that, which become complicated at after certain time. So what happens is companies started thinking about, can't we do something so that this complexity can be reduced, this particular complexity. Can't we do something where we need not to write a code to do the tasks? It should be auto written. There should be some libraries which can automatically provide a brain to the agents. So I'm just writing brain, but without complex coding. That is where Strands agents steps in. Strands agents. They are for single agent. They are not for agentic, all multiple agents. Or no, they are for single agent. What you do is you give a power of reducing and eliminating this coding for the tasks which you want to perform on tools. This is where Strands agents will come in. Actually, it is given to us by AWS. Right? It's a protocol. It's called model protocol. It's not a framework protocol, it's a model protocol. What will it will do is it will increase the reasoning, it will increase the planning without much coding. It's all library based. So agents will going to have additional, or let's say will going to have super brain. And that super brain is actually provided by agent. So you will have one strand agents for agent 1, another strand agent for agent 2, and another strands agent for this, which will eliminate this part. You just need to write one file here, simple four liner. This is my agent, this is my tool, this is the role. That's it. You need not to write how to connect it, what all tasks it should do. No, you just need to mitigate all such things by using this brain. Right? If you come back here, I'll show you. Strands agents, enter. See this. Introducing Strands agents and open source AI agents SDK. So this is actually a SDK which powers the model, means which powers the brain of the agent. If you come here, let me show you. I think it's there only. Yeah. If you come to the user guide, see this. You just need to install this. All done. All done. See this. We are providing the power. So you are from Strands, you are creating the agent. Agent do this. All done. That's it. So you need not to do much efforts in writing tasks. See this. These all are workflows, patterns, and all those things here. Right? So this is what Strands agents are capable of. Here is another catch. This is important. So we have single agent, multi-agent, we have MCP, we have Strands agent, but there is still another thing which is missing. Now, again, I will tell you the problem statement first. Then you will be able to understand why and who will replace that problem. Let's say you have two different agentic AI systems. Two different agentic AI systems. The first agentic AI system is built, let's say, using LangGraph, LangGraph framework, right? And it is having two agents, agent 1 and let's say agent 2, and which is connected to a tool, let's say tool 1 and tool 2. Now, when we talk about the connectivity between these tools, you need not to worry about it. Why? Because it is taken care by LangGraph. This framework is automatically taking care of the communication between agents because it's using a same memory, it's using a same code base, it's using everything, which is same, which is coming from LangGraph. Now think about a situation where you have another agentic AI solution, let's say cab system, right? Automatically cab should get booked for your employees and all those things. They just enter, this is my shift timing, book a cab for me. So that you don't want to put here because it's different. So what you did, you used something called CrewAI, a different agentic framework. And then there are multiple agents related to your cabs. Let's say this is for your attendance, HRMS, and this is for your cabs. So this is A3 and this is A4. And there are tools. So you have tool 3 and you have tool 4. Right? So this is your HRMS, and let's say this is your attendance, present attendance. Right? You are there or not. And this is checking cabs are available or not, cabs availability, and this is booking availability. Now it was working fine. Then one fine day, your architectural team found that these systems can be connected. Now cab, someone is coming, entering, checking. How are you validating the person who is booking a cab is actually available in the office or not? Punched in, punched out or not? To do that, we already have a system. Why can't we connect them? Now this is where a problem and a question comes. You have different framework. This is framework 1, this is framework 2. The communication between these agents, this is okay because they are using same code base, they are using everything which is same. But what if you want different frameworks and the agents inside them to talk to each other? I want this agent to talk to this. 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 I want this agent to talk to this agent to talk to this, and so on and so forth. I want these agents to talk to each other, but for different frameworks. If it's the same framework, no problem. LangGraph or CrewAI or LangChain or Zyper, no problem. They will handle it. But what about cross-platform? What about cross-system communication? How this is going to be handled? Because frameworks are changed, communication protocols are changed. This is where A to A comes in. Agent to agent protocol. So this is what will going to handle this situation. If you want cross platforms, cross systems, cross environments, multiple agents inside them to talk to each other, this is where your A to A will steps in. Right? This is where you are sorry. This is where you are going to have your agent to agent protocol. Right? So we covered just quickly I'll write it down here. We started with AI. We moved to ML. We moved to DL. We moved to Gen AI. We moved to LLM. We moved to RAG. We moved to AI agents. We moved to Agentic AI. In Agentic AI, we moved to frameworks. In agents capability, we powerhoused them using MCP or again, yeah, I think better I'll write here. So you have single agent and you have multi-agent. It's called MAS, multi-agent system. Multi agent. And then we powerhouse them using tool abstraction with model context protocol. Removing the coding which we do by writing separate tasks with complex Python programming. And we introduced strands here. MCP introduced by Anthropic, Strand agents introduced by AWS. And then when you are having a cross platform, again the communication challenges will come, the coordination challenges will come. That is actually solved by A2A, agent to agent protocol. This is given to us by Google. And maybe next innovation will bring something else, something else, something else. But at present point in time, if you are aware of these terms, 1 2 3 4 5 6 7 8 9 10 11 12 13, right, these 13 terms, your fundamentals are absolutely clear when you talk about agentic AI systems, which are autonomously doing everything for us. Now the last lab, what we will do is we are actually going to create one multi-agent system. Multi-agent agentic system. I'm not going to book my tickets, otherwise I need to fly. So what I'll do is I'll just show you how multiple agent works. So we will be having the prompt, right? Example, I am planning a leave or I'm planning a holiday, not leave, I'm planning a holiday. And I want to go to a vacation for, let's say, 5 days. But where to go, I don't know. So what I want instead of going to my spouse, I go to agentic AI system. And I say that from 10th February to let's say 20th February, choose any 5 days, right? My preferred countries are, let's say, Europe, um, let's say Middle East, um, let's say these two, right? Find the best place for me, which is not very cold, which is not very hot. It should not be very cold, it should not be very hot, right? And plan means select the best city out of it. Don't give me options. Options always confused. Find first, then plan, reiterate, and find one city or country and plan the entire itinerary and give it to me. And tell me the budget also. So I'm going to put this thing. So there will be multiple agents which are going to do this. So this prompt will come here, and then there will be multiple agents. Let's say agent 1, agent 2, agent 3, agent 4, and agent 5. Two agents are running parallelly because they are independent. Example, checking weather and checking flights, weather checking and flight checking, right? This is independent of each other, right? With context, it gets this. Uh, Already in planning, the countries are identified. So those countries, weather will be identified. Those countries, flight tickets will be identified. Then it will be submitted to the third one. Now sequential will come. It will, let's say, going to um, reduce the search from 10 to 2 or 3 best countries. And then the optimizer will come, which will going to be a sequential. From these 2 to 3s, identify the best optimized country. So that is done, optimization and all those things. And then finally it will come to the fifth one, which will going to do or prepare the entire itinerary, how many money, etc., etc. Everything will be here. I can create another agent which can book the tickets for me also. I can create another agent which can book the cabs for me as well for the same day and plan everything for me. So this will going to become the entire agentic AI solution, right? And to orchestrate this task, I am using CrewAI. So CrewAI, it will going to be orchestrator. Then there will be agents. And then there are the tasks associated with agents. So you are going to see crew AI, you are going to see agents, and you are going to see the task defined to those agents, right? And which tools they have to connect and etc. etc. And all solution will work automatically for us. Now this is something which we have created, and there is a UI also. So there is a UI also which we created in Streamlight here, Streamlit. So we are going to have a GUI. As a user, we are not going to see what is happening. Everything will automatically going to be taken care for us, right? If I come here, I think there are certain prerequisites. Let me go back. If you see here, there is something called multi-agent demo. If I do ls, if I do this ls, see here. So this is the requirement.txt file. These all are the things which we need. CrewAI tools, Streamlit, generative AI, and python.env. Out of them, these two are already installed in our virtual environment, right? But just to show you that what all are the actual prerequisites, I kept them as it is, right? So first thing what I'm going to do is pip install -r requirement.txt. Sorry. See here, it is done. Now what we are going to do is if I come back here and do ls, let me show you. This is my Streamlit. This is my front end. If I do cat, this is the front end I have written. That what front end should show to a user. This is a front end. Right? I'm not going much into it. So we'll come back here. Right? And this is source. This is the actual place where we have our agentic AI solution. See this. CrewAI.py. So if I cat this, this is nothing, this is orchestrator. If I come here, this portion, if I make it red, this crew.ai, this orchestrator details. Now this is low code. CrewAI is low code. You need to write code, but it should be less. Now come back, and if I do crew.py, this is what orchestrator is doing. See this. So we are taking the libraries, and then if you see here, it is we are saying these are our agents. This agent is for this work, weather agent. This agent is for flight check. This agent is for planner. This for iterative. This is for this. So these all are the agents which we have, which means this orchestrator will going to manage these agents. Let me take it back, bring it here. See this. So these agents, the CrewAI will going to know that these are the agents I need to manage. Then if I do ls, you will see this agents.py. The logic for the agent will be written here. So if I do cat, enter, see this. See here. What weather agent will do? See this. Role is this, goal is this, backstory is this, tool, which tool you have to use and connect, which LLM you have to use, verbose, true or false. So we are defining the agent properties here, what they have to do, what is their role. And then these roles and things will going to be associated with tasks, how they are going to perform these things, how this logic will going to get implemented. For that, you are going to have something called tasks.py. If I do cat to it, so these are the tasks written for them. See here, this is what your Strands agents will going to replace. You need not to code them like this. See this. For weather agent, what you need to do. For flight agent, what you need to do. So we're defining those Python functions and describing them, expecting output, blah, 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 all those stuff. And setting the context as well. Which tools to integrate? You will going to see tools.py. If I do cat here to tools.py, see this. So we are using Serper dev tool here for web searching, for flight also, and for your uh, weather also. So we are using Serper dev tool. You can, if you are having your enterprise tools, so you need to put all the details about your tools here, right? If I do ls here, let me clear a screen. Let's say you are creating more robust and complex solutions. In the same project, you are going to have your mcp.py for different agents. You are going to have a2a.py. You are going to have strands agents.py and all. So you just need to add whatever feature you want to add here. Once done, I'll just, I think Streamlit is installed. Let me do, yeah. Streamlit run, not here. Control C, cd dot dot. My Streamlit front end is here. So Streamlit run app.py. If everything is okay, fingers crossed. See here, it will take some time. What it is saying, it is showing something to install. Okay, let it be as it is. So if you see here, there are some things which it is asking me to add, because this is running on my local Mac, and I think few things will not work with ZSH, and hence that's the reason we are getting few things like this. So let's ignore them, right? I'm just doing enter, enter, enter. See here, there is nothing which is happening here. And if you see here, this is my Agentic AI application. This is how you are going to have your HRMS agentic solutions, your customer support agentic solutions, and so on and so forth. What I'll do is, let me write, I am planning a trip for 5 days between 10th February and 20th February 2026. Right, my preferred destinations are Europe, or too much expensive, Middle East, and Southeast EMEA. EME, right? EMEA. Mm, Suggest me the best cities which should not be too cold, not rainy, um, and the temperature should not exceed, let's say, 20 degrees. Right? So this is my prompt to it, and I'll just do enter. I need not to do anything. So this is what we restricted. Now, if you see here, it is saying Google AI native provider not available, install CrewAI, Google Gen AI. Okay, so they are changing this actually. So Google generative AI that is getting replaced with Google Gen AI. Right, so come back. I think it should work. Otherwise, we need to recode things. But anyways, let's wait. Google Gen AI native provider not available. You add this. Okay, they have given this up also. No. Xcode install, pip install watchdog. Let's wait for 1 minute. Now it is actually asking us to replace um, the Google generative AI. It is not working. Let me do Control C. Come back and UV add. I don't know either UV will be installed here or not. Crew AI inside it. Google Gen AI. I think they deprecated it. I must have. Uh, if you see here, if I do requirements.txt, you will see this. So what it is saying, it is not working. Well, let me try. Let's give it another go. Enter. Mm, and let me do this also, which error it was throwing me. Because it's a local environment, so such kind of errors are expected. Let me do, okay, no. Let me see if I have this prompt available somewhere. Yes. I'm just pasting a prompt, changing few things. Let me see. Yeah, if you see here, thankfully that error is gone. We'll come back and see what it is doing, how it is doing and all. Let's wait. See this? Agent 0 parsing your requirements, targets identified from this prompt, Europe, Middle East, Southeast Asia, fetching weather and flight details. It is working in parallel. And then agent 3, agent 4, they will be best route, planning the best route, optimization cost, and so on and so forth. This is something which we have hard coded in the front end. If you come here, this is where the magic is happening. If I go up, and you will see things. See here. Crew execution started. This is nothing. This is crew dot orchestration dot py. The task started. The first task and second task is running parallelly. See this. Weather forecast and flight. See this. And again, the destination by default in the code we have given Delhi. So it is showing Delhi to this. See this. Once tasks are started, the agent is implementing those logics. Flight analyst agent and weather reporter. The tool execution started. See here, it is using Serper dev tool. So what it is doing a query to flights, query to weather. These two agents have identified the output. See this, Delhi to Paris, and then see here, weather forecast London, come down, down, down. It will do all such things. Delhi to Dubai, come down, down, down. London weather, come down again. See here, Paris weather, come down here. Flights to Bangkok. So if you see here, it have identified things, and the entire final answer is here. So it is saying here is the list of flight options to this. It is saying Paris, London, in Middle East, Dubai, Bangkok. These basis on our prompt, temperature, cold, rainy. So these are the things: Paris, London, Dubai, and Bangkok. These are the four countries it have identified. Come down, down, down here. Come down, 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 down. All things will go to planner, trip planner, blah, 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 blah. All such things. So what it will do is at the end of the day or at the end of the final execution, it will prepare the entire itinerary for us. This is the entire itinerary. See this crew completion happened. Everything is completed. Go back. See this. This is what we have displayed here. So it will show you everything. So estimate cost trip. If you see here, what it have done, it have identified Dubai for us. It is saying Dubai uh, travel dates between this to this is a best place. It's pleasant, sunny days with average temperature around 24 degrees, blah, 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 blah. This will be the cost and how you should do. You should go here day by day itinerary and so on and so forth. So what it does, it actually implemented this entire part for us. So it have identified the flight, it have identified the weather, understood our context, plan, blah, blah, blah. All those things it have done for us. See this. And it is done. So if you go up, 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 this is something which we have uh, displayed there. See this. Perfect. Now it all looks very good, right? Things are working, everything is good. But what happens is there are certain challenges also. It's not that everything will work and everything is going to be super best. So there are challenges also, right? If the entire liberty is given to the agentic AI solutions, um, right? They can do anything, especially when it comes to financial stuff. So in financial, if you are giving them the details or giving them the leverage to do a final decision for your expenses, right? So there might be challenges there. So there are certain challenges. So let me write it here. So if I come here, the few challenges are number one. So you should give controlled autonomy. It should not be the entire autonomy which you can provide to this. So you should always have humans in between, humans in the loop. You should always have. If you give entire autonomy to agentic AI solutions, it might do something which you are not expecting, right? And the second thing is we are relying upon tools too much here. Any bug in the tool might put a very great impact on your entire agentic AI solution. Third thing is confidential data security. You need to make sure that uh, confidential reports, confidential security details are not going beyond. So you should have a boundary specified for your agents. Otherwise, it will be too much. Another problem is in your agentic solutions, they go in a loops or iterations. When they are going in a loops and iterations, what actually they are doing is they are consuming tokens. Everything is paid. They are consuming tokens. And when they are consuming tokens and the end result is not coming and they are going in the infinite loop, which happens quite often, what happens is your cost will drastically increase. Drastically increase. Fifth is although we have A2A protocols available, but multi-agent coordination is still a problem. Multi agent coordination. So for your complex solution, still the innovation is going on, right? One thing which I want to specifically mention here, specifically being from the infrastructure side, the observability and debugging is still lagging. Example, when you talk about your infrastructure, your applications, your databases, you have a very good observability, your solu- observability solutions available. But when you talk about agentic AI ecosystems, you are still lacking the observability solutions, right? So, and there are many other things also, but these all are the things which we have to carefully consider whenever we are talking about creating agentic AI solutions. Even the debugging is not very simple. When things fail, it's very difficult because you cannot do entire tracing, where things gone fail, which agent is responsible for that. It's not easy. So debugging is also a big challenge. Memory misuse is also one of the challenge actually, right? So you have some old memory, the new memory come, it get confused in the your vector database. So vector DB pitfalls are still there, um, and many other things. But I think as far as the fundamentals and intermediates are concerned, probably um, this is what we have today. Super. So I am